Well, in this episode of Finno-Greek machining, we are going to make the air oil filter, liquefying air oil filter for this air oil separator. Well, let me show you something. Well, this is the material I'm going to use. It has some spider webs inside and some rust and so on. It's just a 70 millimeter steel tube which has a 3 millimeter wall thickness. The idea is to get rid of the paint and then thread, well, of course make it like square and then do threads inside there to accommodate so that I can screw this workpiece into there. This is the valve. There is this valve thing inside and yeah, so well, what I need to do is now to cut it in suitable pieces and then go on from that. Well, now the workpiece is here in the chuck. And the next operation will be to straighten it out. And yeah, it's quite straight already, but I have here this, well, let me show you. This is a ball bearing here. And this is just a tool to make it straight. And now I'm pushing it very, very gently. Like that, and then I'm pulling this out from there slowly, and there you are. Well, it's as you could hear, it's not entirely straight, but it's straight enough. And now one thing about this chuck and chucking this kind of a tube, you don't tighten it really tight. Well, you tighten it tight, but not really tight. Okay, like that. And now, next step, I will face this area and trying to be very gentle with that one. I'm going to use this VNMG for that operation. So let's see how this goes. I'm searching for the maximum there. It's there, I believe. Let's see. Yeah, there you are. Then I lock my carriage at this point. I'm going to use the top slide, aka also known as compound, to feed. Okay. And I can see that it's hanging over like that. I don't like that. So I will furthermore push it back a little bit so that I can have it so that the chips don't enter the vase there. There you are. Now it should be. Let's see if it can rotate freely. Yes, and now I need my safety goggles. Okay, I will now change your camera angle so that you can see a little bit better what is happening here. Okay, now I'm going to clean the inside of this tube. And well, we have a certain dimension which we cannot exceed. I'll see how clean can I get it, but so far it looks really nice. I already a little bit tried at the edge here. So, and yeah, so this is running really slowly, something like 180 revolutions per minute. And the feed is really slow, like 0.038 millimeters per revolution, 38 microns per revolution. And is it? Yeah. And well, I hope I can get the rust away there. This is a very flimsy setup, so it might start ringing. But we have this variable, this speed modulator, which should help in this case. This is quite, if you listen, it can create sounds. Another method would be have here around something like a rubber band or something. But I think we can do with that, without that. And then I have a carriage stop. I will do it almost all the way. And then when this side is ready, we are going to make a thread here. And when that is ready, I turn it around and do the same, the rest which is left here. There will also be a thread. And then this particular piece is ready. But now let's clean it up. Well, it cleaned up quite well. This is now a little bit under 64 millimeters in diameter, and we need to pour a portion of this to 65 because we are going to make M66/1 thread into there, and the tapping size would be like 65 millimeters for that. So and you could also hear that I have switched on the speed modulation because it actually prevents this from chattering quite well actually. So now let's decide the portion, how much we need to have there. I think if we are now there, and now if I take 15 millimeters, that should be well enough. So I set my carriage stop here. It was a little bit tight, this one, but now it's there. Now it stops there. And now if I go back to here, I think it was this. Let's touch it. Oh, whoa, 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 whoa! That was bad. Too hard touch. No, it's not too hard actually. It was. Well, let's take 0.2 millimeters away from that. Oh, here we go. And the feed is really slow at the moment. I will measure this after this cut, and then I will see how much more we need to take. Let's measure that one. Yeah, of course you don't need any chips under there. That would be ruin your measurements. Would be ruin. Yeah, it would be a ruin after that. Yeah, looks like it's 64.2. So 0.8 millimeters away from that. So now just turn it. Like that. There you are. Wow. Now I just measure it and let's see how near we are of this, our goal. At least the surface finish is really good. Only one chatter line there. Yeah, it chattered. Without this speed modulation it would have been chattering all the way. But oh wow, what a click. Okay, should be 65. So let's see. Well, if that's not 65, then that's, yeah, it's 65. Okay. Now, next step is to set up the boring, the threading here. Oh man. Yeah, okay. I'll set this up and come back when I'm ready to start trading. Well, okay. Now I'm going to make the thread in here, and this will be 1 mm pitch. I already made a groove there where the thread starts. It's inside there. I have the carriage stop so that I can well easily start it, and I will use the cross slide, the main slide to do this. So my first cut will be 0.25 millimeters, and yeah, and of course, because this is let's now check this. It has to be run the reverse direction. Yeah, it's feeding the correct way. It's very important. So 0.25 millimeters, and yeah, and first, yeah, there will be some lubrication needed here. Well, hopefully I can do this, and well, now we go. This is the first round around. Well, it didn't work for some reason. Maybe now. Yep. And there you are. Let's see how it looks. Looks really good. And now you need to remember to push the tool away from there and then come back to here like this. And yeah, I can actually turn this so that I can get my, yeah, this is a very good idea to get your half nut already connected, because this lathe has some peculiar behavior when it's not. So now this is going to be the next round around. Yep. Let's see. Okay. And then the tool there, and then we go to 0.5 millimeter. And again, I try to make this. I'm rotating this by hand, so to say. Try to get the half nuts connected, because these have a very strange behavior when they connect. Oh, okay, now we are approaching. There you are, now it's connected, and this is the next one. Now we go. It's less hassle when you do it like this. Okay. Okay. Yeah. Wow. Then we go. Yeah. You can connect this while running, but this has so little room there that it's better to do it like this manually. Connect it in advance and then just go. And now I will do a few spring passes with that 1 millimeter setting. you are. And now we go. There. Yeah, that was a real spring pass now. This thread should be quite ready. Let's see. Yeah, it's a little bit tight. I need to... Oh yeah. It's a little bit tight, so we need to take 0.1 millimeter more, I believe. Well, let's see now. So 1.15. Oh, this is not... Oh, now it goes. There you are. I think we need to take a few more spring passes here. There you go. Let's see if it fits better now. Well, actually the threads are really looking nice, but they are just looking nice as long as they don't work. That was the wrong one. It's not easy to thread in this one. And now it locked up. I will stop now fiddling with this camera. What I will do next, I will take some emery and take the edge away from the top edge from these threads, and then I try it again. If it doesn't work, then I'll dig them a little bit deeper. Well, yeah, this is a little bit of a trial and trial and error, error and trial, whatever. But anyway, now I will shoot off the camera and come back when the thread is okay. Okay, now we have a very, very tight, not tight, but good fit thread in there. And it goes, when you get it straight, this is very easy to thread like, of course now when I'm trying to, okay, now it goes. So it goes very easily in there. Doesn't require any force, but it's still like really tight. There is no play. Yeah. And there you are. It goes all the way in, so I can put some sealant in there and it will stay in place. Really it will. It won't come off. So, yeah, okay. So this part, this side of this thing is now ready. And well, it will be a rinse and repeat for the other side. I will do the same trick at the other end. Okay, now I will turn this around and use my ball bearing tool to center it and etc. That's just what I do now. Well, now I have I have threaded both ends of this cylinder, and now what I'm going to do next, I will attach it to this workpiece. This is the valve body, and I will screw this one in here so that it will be airtight. And I'm pretty sure it will stay in place after I do this. I'm using this well, hilariously pink Loctite 510, which I just squeezed some of it in here. Hopefully it now comes out from this container. It seems to be quite stubborn. Ah, there is a locking system. Okay, yeah, now it comes, I believe, yeah. So I will put here a bead here at the very bottom. This is anaerobic sealing agent that will seal after it has been not exposed to oxygen to some time, or air, I don't know, whichever makes it rock. But yeah, now that we have it there, then I just take this. Hopefully it was this side. I can tell it right away. Yeah, it is this side. I have my gloves here in case I need to. As you can hear, it's really, I would say, really tight actually. Now let's tighten it. This will actually glue it a little bit on the place, so yeah. And now the final tightening with props. No, they didn't help at all, they slip. Okay, it's there. Well, there you are. Now we have it there. And the next step is to, well, take the extra out from there. But I leave it alone for a while here. It's well, the pins you saw there, they were just to support this, and they were exactly suited for those holes, so that I don't damage the sealing surface. But I can still slip it after this operation, but yeah, okay. Now it's there. Next step is in the next episode. Okay, that was it. It's as simple as that. It's now there being anaerobic and trying to become hardened, to cure itself. Yeah, it will, most of it. Only the parts that are outside the thread will not cure. And I'm pretty sure it will be airtight after that operation. Well, that's it. And in the next episode, we are going to make this, it's the other piece of this which contains the tilted holes. It will be a challenge to mill those holes or drill those holes. Those need to be not too wide holes, so that there will be some air speed there, but not too thin either, so that there is some airflow. Oh yeah, okay. Maybe I can figure out what is the best solution there. But that will be in the next episode of Finno-Ugric Machining. And as you can hear, my throat is already in a very good condition. Yeah, and hopefully I don't catch that one again. It was a little bit painful. Okay, till next time, bye!